So in this lesson, we're going to look at prime factors. Now, prime factors are the building blocks of numbers. And we're going to look at these, and there's a great technique we're going to look at to finding these for a certain number. So we're looking for the factors of a number, but only the ones that are prime. So in this first example, we're looking for the prime factors of 36. So we're going to start off with 36. And we're going to start to break it down into its components. And we're going to do that by thinking of two numbers that multiply to make 36, or in other words, two factors of 36. So you could do anything at all. It's always going to work, but let's start this one off by doing 6 and 6, because we all know that 6 times 6 is 36. Now, are any of those two numbers prime? No, 6 is not a prime number, so we're going to carry on and break the 6's up again into even smaller components. So 6, of course, is 2 and 3, timesing together, so this one's quite easy to do. You never want to do 1 and 6, the number times itself, because otherwise you're going to go on forever and ever and ever with your factor tree. Now, once we get some prime numbers, we're pretty much finished. Now, in this particular case, all of these numbers, the ones I'm circling, are primes. And once we get to a prime number, we stop. And it turns out that if I multiply these things together, 2 times 3 times 2 times 3, I'm going to end up with a grand total of course, 36. So there we are. We've found the prime factors of 36. The prime factors are 2 and 3. And I can write 36, if I wish, as the product of its prime factors, which means 2 times 2 times 3 times 3. Often the best way to write this is in index form, so 36 is 2 squared times 3 squared. And there we go. We've gone a bit further in that question than we needed to, but that's how we do it. Now, let's have a go at some more. These ones look a bit more complicated, so we'll start off with 102. Now, so 102 is a bigger number, and it's hard to think sometimes of things that it's going to divide into. So, easiest thing to do, of course, is it is obviously an even number, so it's going to divide by 2. So, if we divide it by 2, we can split it up into 51 and 2. Well, of course, 2 is a prime number, so we'll circle that one. So all we now need to think about is determining if 51 is a prime or not. Now, I have no idea if it is, so I'm going to cheat and I'm going to use my calculator. And it turns out that, yes, it is not a prime number. It divides through by 17 times 3, so 17 and 3. So I can split it up like that. And are those prime numbers? Yes, they are. So I can circle them, and now I've got my pattern. I've got my prime factors of 102. And the question asks us to express this as a product of its prime factors. So I'll write it up here. 100 is equal to 2 times 3 times 17, and that is the answer. Now, 60, let's do this next one. 60, I could split it up into 2 and 30, and that would work, but it's going to save a bit of space if we split this up into 6 and 10. It's probably better to split it up into numbers that are closer together. So if I split this up into 6 and 10, well, neither of those are prime numbers, so I'm going to split them up again. 6 is 2 times 3, and 10 is 2 times 5. And all of these numbers are prime, so I'm almost there. That's me identifying the prime factors of a number. All that's left is for me to write out this as a product of its primes. So 60 is equal to 2 times 2 times 3 times 5. We're almost finished. Let's just neaten this up a bit by using index form. I've got 2 times 2, so I'm going to write 60 as 2 squared times 3 times 5. Now, in this final example, we've got this whole concept working backwards. They're giving us the prime factors. There it is, 2 cubed times 3 squared times 5. They're asking us what was the original number. So we've got to do some calculations now. So 2 times 2 times 2 times 3 times 3 times 5. Now, if you're doing this without a calculator, the easiest thing to do in your head is to double something. So we'll save the timesing 2 till the end. So let's just look going backwards. Well, we've got 5 times 3, so that's going to be 15. 15 times 3, well, that's going to be 45, and then we're going to start doubling. So 45 times 2 is 90. 90 times 2 is 180. And 180 times 2 is 360. And so the answer to this question is 360. That was the original number. Okay, this is all you need to be accessed the next exercise. Good luck.